Hello, this is No Static, and we are going to solve a simple annuity problem of the type needed for the Financial Mathematics Actuarial exam. First, the problem. Three friends, Julian, Ricky, and Bubbles, wish to set up a retirement fund with a single deposit today. Julian wants the fund to pay $1,000 at the end of each year for 3 years. Ricky wants the fund to pay $3,000 at the end of year 1, and Bubbles wants the fund to pay $500 at the end of each year for 6 years. If the amount they invest will grow at 10% each year, what amount must they invest today? Well, we are asked to find the present value of what each of these three individuals desires. We'll find the present value and we'll add those three present values up, and that will arrive at the answer of what amount they must invest today. So let's begin. The first thing we need to do is talk about what the important variable is. And for this problem, the variable of I is the interest rate is given to us as 10%. So we write that as a 0.1. So I is 0.1. And then nu, which is the present value discount factor, is defined as 1 divided by 1 plus I. So in this instance, nu is 1 divided by 1.1, and that's 0.90 repeating. So that's the present value discount factor which we'll use in order to figure out the present value of what each of the individuals desires. First, let's talk about what Julian wishes. Julian wishes to get $1,000 at the end of the first year. So we take that $1,000 and we multiply it by nu, the present value discount factor. He wants $1,000 at the end of the second year. So that second $1,000 gets multiplied by nu squared. And he wants a third $1,000 at the end of 3 years, so that gets multiplied by nu cubed. So that is an expression which gives us the present value of what Julian desires. Now, there's some actuarial shorthand for this expression, which I'd like to write down too. That is 1,000 times A 3.1. So that stands for, the A31 stands for a sure payment of $1 at the end of each period for 3 periods where the current interest rate is 10%. And so when we multiply that by 1,000, it's a sure payment of $1,000 at the end of each year for 3 years with an interest rate of 10%. So that is the shorthand for our present value for what Julian desires. Now for Ricky. Ricky simply just wants his $1,000 or $3,000 at the end of the first year. So his present value is 3,000 times nu. He'll get that 3,000 at the end of the first year. And lastly, but not least, is Bubbles' desires. He wishes to have 500 at the end of year 1, 500 at the end of year 2, 500 at the end of year 3, 500 at the end of year 4, 500 at the end of year 5, and 500 at the end of year 6. So that's quite a bit to write, and when we write this in actuarial notation, you'll see that this makes this much easier to write. This is just 500 times A 6.1. Much simpler than the long expression. Okay. So we have an expression for each of the present values. Now we want to find out what they are, and to do this, we'll use a financial calculator. I'm going to give instructions for using the BA2 plus financial calculator by Texas Instruments. So with the calculator on, we'll figure out Julian's first. We're going to hit the number 3, and then we're going to hit the button N, which will store 3 as the number of periods. We're going to then hit 10 and hit the button I over Y, which will store 10 as the interest rate. Note that you put in the percent here, so 10, not 0.1, 10. Then we'll put in 1,000, and then we'll hit the PMT button. He wants his payments of $1,000. And then lastly, we'll put in 0 and hit the FV button. The future value, the amount remaining in the account, will be 0 at the end. So we put in a 0. We've put in values for N, I over Y, PMT, and FV. We have not put in values for PV, the present value, because that's what we're computing. And now we can simply hit the compute button, which is CPT. And after we hit the compute button, we hit PV. And you'll have the answer for what Julian's desired present value is, and that is $2,486.85. And the calculator has a negative sign there. We'll just ignore that for now. That's not important for what we're doing at this point. It will be important for more difficult financial mathematics problems. Now let's talk about Ricky's. We're not going to use any special calculator functions here. We're just going to take 3,000 and multiply by new, which is just 3,000 divided by 1.1, which is $2,727.27. So that's how much Ricky's present value is, and Bubbles' desired present value. We're going to use the calculator again. I'm going to hit the number 6 on the calculator, and I'm going to hit N after 6. And I'm going to put the number 500 into the calculator, and then I'm going to hit the PMT button. So now what I've done is I've stored 6 as N and 500 as the payment. The 10 for the interest rate and the 0 for the final value are still stored in the calculator, so I don't need to hit those again. Then I just simply hit the compute and present value button, and I will have Bubbles' present value listed here. It's $2,177.63. So now I have each value, Julian's, Ricky's, and Bubbles, and so now I can add them together for the final answer. So the answer is the sum of these three numbers. It's $7,391.75. Okay. Thank you for watching.